Again, I know the last video cut off on us, and I'm sorry I did not catch it, and you missed a lot of this, so I'm going to rehash this. I just won't be drawing along with it. But what happened here is that you had a situation where from here to here, we don't, we have the height being the difference between these two equations right here. So this region right here would be consisting of x to the 2/3 minus x to the 1/4. That is not right. It would be x to the 2/3 minus x minus 4. So now we've got to take this equation right here and let's see where they equal to each other. So I've got this right here. I've got that x squared equals to, now qing both sides, I get this is x cubed minus 12x squared plus 48x minus 64. All right, well, continuing on from there, I would get that 0 is equal to x cubed minus 13x squared plus 48x minus 64. Now, I get to here, again, I'm trying to figure out where this intersection point is right here. I know it's going to be greater than 4, so let's just see if 8 works. Again, just using the theorem where we're going to, well, I'm drawing blank on it. Rational roots theorem, yeah, that's it. 8's going to be one of those possible rational roots, so let's try it. So we've got 8, and this would be 1, negative 13, 48, and negative 64. Plugging in, I get 8, then I get 8, I get 1. 8 and 1 is 8. This is negative 5. So then you'd have negative 40. 8 and 8 is 64. So we get that 8 is this other value here where they're equal. So this is going to be 8 here. So my second region where I've got this equation, x to the 2/3, take away x minus 4 is going to be from 4 to 8. And now I'm going to go about integrating it. So clear this off. Antiderivative of x to the 2/3, that would be plus 3/3, so it would be x to the 5/3. So we get 3/5 x to the 5/3 plus. All right, now it again would be minus 0 when we plug in 0 here. So now I'm to this integral right here. So once again, this is 3/5 x to the 5/3 minus, it's going to be minus x plus 4. So it's going to be minus x squared over 2, and then plus 4x. And we're going to go from 4 to 8. Okay, so I'm going to rewrite this as 3/5 x to the, or times 4 to the 5/3. Again, that would be minus 0, so we don't care about it. Plus, all right, now plugging in 8. The cube root of 8 is 2. 2 to the 5th power is 32. 32 times 3 is 96, so I've got 96 fifths right here. All right, now minus, okay, this would be 8 squared, which is 64. 64 over 2 is 32, so I've got minus 32. And then 4 and 8 is 32, so plus 32. So those can go play with the dodo bird. Now I've got to subtract. So I'm going to be subtracting 3/5 times x to the 5, no, times 4 to the 5/3. All right. Now plugging in 4. 4 squared is 16. 16 over 2 is 8, so it's going to be minus 8 here, and then 4 and 4 is 16. But it's, all right, hold up. All right. I'm subtracting this, so this would be plus 8, and then this would be minus 16. All right. So, and again, this right now, this is my third time to work this problem because of the video mishaps. So we've got 3/5 x, so that goes away with that. So now I've got 96/5 minus, all right, this would be 8. So 96/5 minus 40/5 is going to be 56/5. So that's going to be my area right here. Now, in just a second, I'm going to do a fourth video. I think it's the fourth video. Anyway, on the fourth video, we're going to take this same problem, but we're going to look at it a little bit differently, and we're going to look at it and how we can make it even a simpler problem than this. This is not very simple, but we're going to look at how we can break this integral down and do it in an easier way.